Hi everyone. So when we stopped the recording last time, we saw a situation where it takes around like more than 3,600 simulation seconds. So usually it might take a bit more time than that if it's a 1 hour simulation, but in our case, it's almost double the time, right? So this is something uh, like we shouldn't expect from a simulation run. So ideally, it would be best at this stage to kind of investigate it and see whether we can do some improvements to it. So that is what we are trying to do in this session. So uh, we'll see how we can do it. So if you haven't considered to my YouTube channel yet, I invite you to subscribe and join, and so that you can get more information on the content as such. So we'll see how we can do it, right? So at the moment, if you simulate, or rather, if you rerun the simulation, you will be seeing vehicles in a like a single color, but it doesn't give you much information about the let's say the traffic that has been built, right? So now, depending on, like, for example, if you look at vehicles over here, so probably there are queues are being formed, and we want to kind of visualize what's the waiting time at each for different vehicles, so that we can see whether there are any potential bottlenecks in this network. Now, Sumo can do that if you click on this edit configuration, or the view settings button. And now, at the moment, we are using a color for a given vehicle, but you can also do something called you can leave it by the accumulated waiting time. Now, that will give you a different story. For example, what it says is, if the accumulated waiting time is like around 0 second, so the vehicle will be shown in blue color, and as the accumulated waiting time increases, the vehicle kind of become red. So if you look at the vehicles over here, you see that there are a bit more waiting time for them, and also maybe probably over here you would see some bottlenecks. All right. So one thing is obviously whether we can, let's say, sometimes we might have to adjust the signal timing, which we haven't included yet. This is still running on its default signal timing, but we can do changes to that as well. Uh, but also we can do some other changes with the current setup that we have. Now, the current setup that we have is predominantly governed by the route, or rather route whitelist, that this random trips Python script provides, and also how it's being handled through routeSampler. Right, so we try our best to do whatever the changes that we can do here, and then after that, or rather in parallelly, we can also look at how we can uh, add the signal timing plan as well. Right. So now, the wave setting that I've created here, let me save this. Right. So settings, say accumulated time. So this will be my new setting. It's fine. And so I'll close this, and I'll change this to accumulated waiting time, and then let me rerun the simulation so that you will see. Right, so using the colors represented by, or rather colors will be changed based on the accumulated waiting time. Now one thing is that still we don't see much, but if you if you look at over here, you might be seeing there are some bottlenecks, or rather, yes, some queues are being formed, probably because of the traffic lights over here. But what initially I want to show you is that now is that there are different things that might cause this, right? And it might be different depending on the network that you handle. But in this case, what I found to be uh, the changes that need to be done are as follows. Now, for example, if you look at this network, this is a part of a very large network. So usually the vehicles should start to enter to the simulation from these like ending edges, what we call the fringe edges, right? Something like this, right? So ideally, a vehicle should not be generated using somewhere like here. For example, this edge CRMP 012, right? Now, vehicle shouldn't be generated from a edge like this, right? Or rather, a vehicle should not be enter into the simulation from an edge like this. So CRMP 102, 012, sorry, CRMP 012. There are 359 cases as such, but let's see whether there's at least any route that starting, yeah, probably a wrong example, but let's say 06. Sorry, 06. Sorry, 006. All right, so probably let me try to run this again. Would have been the reason. Yeah, let's check the right list one more time. Uh, yeah, so here you see that a trip is starting from an edge like this, right? So there's a route in our whitelist that a trip starts from there, right? So if you go through this file, you will see a bit more examples like this, right? So ideally that should not be happening. So what we should do is we need to have some controls over it. Now, if you go through the right, if you go through the random trips, you will be seeing some changes that you can do, right? So for example, you can do some changes to the edge probabilities. We'll come to that bit later. And also, let's see where we can find so we can use a factor called fringe factor that increases the probability that the trips will start or end at the fringe of the network, right? So we don't want trips to start at and end at in the middle edges of the network, but rather than that, we need something to be ended in the start from the edge, start from a fringe, and also possibly end at a fringe. Now, by default, it's 10. So it says edges that have no successor or no predecessor will be 10 times more likely to be chosen as start, right? So I want to increase that, right? So I want to increase it to, let's say, somewhere 300, right? So this I have tried and tested multiple times. That's how I tell this number. But I mean, it's there's no actual meaning for that, right? That doesn't guarantee that you also start with 300 or something like that. But this is a value that I came up with by testing multiple times, right? So fringe factor 300 is something we can look for, or rather, fringe factor is something that you can change. And in addition, I'll be adding a new couple of changes. So for example, max distance, I'll say 5,000. So I'll be saying here is that the routes, the length of the route, the maximum length of the route can be around 5 kilometers, because the network, if you look at from starting point to the ending point, there's around like from here to here, there's around 5 kilometers. So that's why I have chosen that. So those heuristics will be chosen depending on the network as well. Also, I'll tap the minimum distance, let's say 200 meters. So I shouldn't have any routes that are less than 200 meters in length. And also, I will say that now, if you look at the edges, now this is the main road, and these are like the sub roads that are connecting to it. So obviously the speeds are different to it, right? So if I hit Control T and go to the network, you will be seeing that the speed of an edge like this is 16.67. That is closer to, I guess, 50 kilometers per hour, but whereas here it's 5.55, right? So around 15 or around 18 kilometers per hour, the speed, right? So usually more trips should be started with, or rather, more routes to be sampled, or rather, more routes should have this higher speed edges and less of these, right? So that can be governed by, or rather, if I show it in the documentation itself, there is, yeah. So there are a couple of probability factors that you can do, right? So you can use the edge speed, right? By the number of lanes, that's also possible. Edge length, right? So there are different types of methods that you can do, but for this case I'll be using speed exponent, right? So let's use that as well. Right, so I'll set 4.0. So this is again a value that I came up with by testing multiple times. And also I'll change the period to 0.1. Let me see if I can find the documentation for that. Yeah, so arrival rate, right? So the traffic arrival rate is controlled by the option period. By default, this generated vehicle with constant period arrival. Yeah, one divided by arrival, one divided by period. So by default, it's one. So only 3,600 vehicles routes will be generated. So I want to have multiple arrivals per second. So I'll change it to 0.1. This is again a value that I came up with by iterating multiple times, because now that you have a script based approach, you can rerun it and visualize your performance of your simulation, and then based on that you can do changes, right? So that's the benefit of getting things to a script like this. So let me run this. Okay, is there an error or something? It should be I saw something that is not right. Okay, it's not fringe factory, it's fringe factor. Okay. Distance, speeds, export, and get it fine. Yes, I can run this now. So a new whitelist will be created now. Yeah, so now you see the mapping is like almost 98%, 99%, because now we have like routes. The route whitelist is more rich, so that my traffic counts can be mapped, right? So it's almost 100% mapping is done. So in a way, it's good. I mean, we'll now see whether still there would be any bottlenecks, right? So probably we still seeing that the vehicles are still entering from one lane that we can correct. But let's see whether at least this reduces the simulation time or do any change at all. So think a lot of vehicles in simulation, but let's see. You see, there are some. I mean, yeah, you see some bottlenecks. Probably, yeah, it reduced, but not to a satisfactory level. But anyway, so there's one more change that we can do, is that we can change the the way that vehicles enter to the simulation. Now, for example, if you have get over here, it just say the vehicle ID in the mapped route file and the depart time only. But it doesn't say the depart lane, decide speed, and everything, right? So we can correct that in the route sampler level. Uh, we'll do that change as well. Try to show it in two steps, right? So I'll be let's do that. So I would say attributes equals let's say depart lane equals, that should be free, and then we can use something like this. Yeah, I think this should work. Desired, and then you have to escape this character. Let's see. I think this works. We'll see how it goes. Okay, there's a invalid escape. Okay, let's see how the file created. Okay, there's a okay. So this is what it does, right? So it depart lane free, that is correct, but depart speed, there's a issue, right? It has to be something like this, right? So I think I have a additional escape character. That is what it said to me. Depart speed, depart speed. Yeah, probably this should do it. Oh, let's see. think it's okay now. Yeah, so now you have something like this, right? So if I rerun this, you'll see what happens now. Because now vehicles will be entered simulation using both, like all the lanes that are available to it. So let's see how it goes. Yeah, almost there, but let's see. There are certain errors, right? So may have to like take a closer look at them, but we'll see whether the rest of the changes can be implemented and make it whether we can reduce the simulation time. All right, so yeah, so again, still the time is there's an increase, right? So I guess this is the best we can do with this changes that can be introduced through these files. So we'll end this video from here, and on the next video we'll fix the remaining parts as well, and try to reduce this time further. Right, so I'll see you on next video then.